Very nice. Can everyone hear me? Good. I just wanted to thank the organizers of PyCon so far. It's been great. If we can just give them a hand. I've had a lot of fun so far. Thank you. My name is Chris McDonough. I am a open source software developer that hails from the beautiful state of Virginia. And I am the original author of the Supervisor process controller, which I'll be talking about today. I also developed Pyramid Web Framework and a bunch of other stuff. I work for a company named Agendaless Consulting. They're a very small consulting company. If anyone needs help in Python or either in stuff that we've done or else otherwise, let me know. This is who I am not. I feel like a bit of a fraud up here today because I haven't done much maintenance or improvement on Supervisor in a long time. And the guy who's really responsible and deserves all the credit is a guy named Mike Naberezny, who took over maintenance maybe 5 years ago and has done a fantastic job. So I'm just here to tell you how it works, and I do contribute now and again, and I'll probably contribute it more in the future, but he's the guy who does most of the work. So what is Supervisor? Well, Supervisor is a Python application that lets you control process state on UNIX-like operating systems. Linux, OS X, BSD. I think it probably still runs on the various Solaris offshoots, although I don't think we've tested it that recently on there. And so what does that mean? Well, it's a program that runs other programs. It's a Python program. It's extensible in Python. You can run Python programs with it, but the things that run under it do not need to be Python programs. They can be any old kind of program like Redis or Apache or Nginx or Postgres or whatever. It is not a Python-specific thing. So this talk is really aimed more at systems administrators who need tools to keep things running, and also maybe developers or development managers who need a tool to help people build development environments that are easy to set up. And Supervisor is something that will help you with either of those things. It is configuration file driven, which means you have a configuration file that represents some set of processes. The set of processes is usually related to some sort of project you're on. Let's say you're writing an application that requires a web server, requires a database, and it requires like a caching thing like Memcache or Redis or something. It's sort of like systemd or Upstart in that those programs also run other programs, but Supervisor was never meant to be run as PID1. It was never meant to be run directly from, as your computer boots. It's just an ad hoc per project sort of thing. So rather than try to explain the configuration file format, I'll just show it to you really quickly. We have several sections. This is a supervisord.conf. That's the conventional name for the file. We have several sections in there. One is about the server. The Supervisor is a sort of client-server program. There's a program named Supervisor D, which starts up, and that's what starts all your other programs and keeps them running. And then there are a number of ways to actually get into to control the processes that get started after they start running. All communications with Supervisor D happens over HTTP, and it's basically a web server. So we're telling it here, run an HP server on port 9001 of localhost. You can also, if that bothers you, you can use a Unix socket instead of a TCP socket, so that no one can get in if they have access to your local machine, and you can protect that with a file thing. But in any case, in either case, it's running an HTTP server. Then we have sort of this generic configuration stuff that is about Supervisor D itself, where its log file goes and some other things. Not very important right now. We give it an RPC interface. This is one area where Supervisor is extensible. You can actually add more commands to Supervisor under the hood by adding more of these RPC interfaces. This is the main one. This is the one that the controlling programs use when they connect to it. And then we also have this section in here that's read by the controller program, which I'll show you later. It's not very important right now, but the only important thing is that it points to the same port 9001 as the daemon is running. So all that said, that's not much fun. That's all just sort of bookkeeping. The thing that most people are interested in is running other programs, and this is the simplest possible way. This program : clock thing here is the simplest possible configuration to run a command, to run a program. And if you'll notice here, the command equals line points at a Python script. It happens to point at a Python script. This is just for purposes of demonstration. Like I said, Supervisor will run anything. As a matter of fact, I should mention that most people who run Supervisor couldn't care less about Python. They're PHP people or Ruby people or Java people or whatever. They couldn't care less about Python. When we start up Supervisor D in this configuration, which I'll do in a second, it's going to run one instance of this program, this clock.py program, which I'll pull up really quickly to show you what it does. This clock.py program is just a loop. It prints the time, and then it sleeps 2 seconds. Okay? So this is just, this could be anything. This is just what I'm using to demonstrate the thing. So I'm going to go over to my terminal window here. I'm going to start up Supervisor D. This bit of this -C flag that I'm using here is optional, but this is how you specify which configuration file to use. And usually you'd start it like this, and it's going to put itself in the background. Oops. It's going to background itself like that, and that's typically you get control back at the terminal when you start Supervisor D. I'm actually going to shut it down, and I'm going to start it in foreground mode under a set of flags. -N means don't demonize, and -edebug means print debugging info to the screen. So we'll be able to see it sort of doing its bookkeeping as it runs here. So sort of interesting stuff. It says that the Supervisor or the clock program, it spawned clock with PID 2848 down here. Sorry. And we can see that clock is indeed running, and it's spitting out stuff to its own standard out, which is then captured by Supervisor. And Supervisor then lets you tail the log file or sort of just examine the log file from the program's standard out. Very simple, not very complicated. So now that we've seen the configuration file and sort of how to start it, I'm going to go back. I'm actually going to stop it again. And when I stop it, the programs that it started up are now stopped. So once you stop Supervisor, the programs that it started up have gone. Quickly go back to my slides here. So once we have some programs running, that's fine, but we're going to want to control them in some way. We're going to want to start and stop them and see their output, and maybe even write a little program that lets us examine their state as they're running. So the Supervisor D daemon actually lets you use a web interface, a command line tool, or you can use XMLRPC. Who here has used XMLRPC before? Okay, lots of people. So XMLRPC is just, it unfortunately has the letters XML in its name, but you never see XML. It's just a way to talk to a remote process over HTTP that's very handy, and Supervisor uses it heavily. So you can use the same APIs that the built-in tools use to control process state if you want to do that. So the first thing we'll see here, I'm going to go back and start it up again so we can see it. So this is just a GIF of the web interface. The web interface to Supervisor is controlling programs that are running under Supervisor is pretty weak. It doesn't do a lot. There are lots of things that you can do under other ways to get into it, the controller program and the XMLRPC interface that the web interface doesn't do, but it's handy and it works. I'm going to go to it now, and we can see that program that I started up called clock is running. and it's been up for 30 seconds. You can see it's PID, all that good stuff. And basically, all you can do in the web interface is restart it, stop it, clear its log, or see its log in real time. And it's, so we can hit restart. It restarted. Okay, not very interesting. The way that I usually use Supervisor is I actually use the command line called Supervisor CUDL, which is the sort of client interface to the same program. It also takes the configuration file as an option, and we can see that when we use it, it's a little wonky here because it's wrapping, but okay, now it's not wrapping anymore. We can see that when I type status or hit enter, I can see all the programs that are running under Supervisor. And you can see their PIDs and how long they've been running for. So we have one program running now, it's the clock program. And well, what can we do with clock? Well, we can tail its output like that. So we see that it's doing stuff in the background. We can restart it. All right. We can stop it. It's right twice a day. And as we do these things, we can see that indeed this, the status of this thing is now stopped, as if we stopped it. We can take a look at Supervisor's own log file through the main tail command and see what it's doing to try to stop the thing. We can get a sense of what's going on in the background. So I am going to go ahead and slide. So we've seen that we can stop, we can start, we can restart. We can do a status, we can do a tail, we can do a main tail. We can also do a reload, which rereads the configuration file and basically restarts Supervisor D, which is useful sometimes. Or we can shut down Supervisor. So from there, these are sort of the basic things you can do with processes. More advanced things you can do with Supervisor CUDL is you can actually change the configuration file, add another section. I'm gonna try this here. We'll just go ahead and uncomment one of these things. Uncomment this cat program, and we will go and we'll say avail. We're going to reread the configuration file. It's telling us that we added this thing called cat. Type avail again. We can see that clock is already running. We don't have to stop. We don't have to stop Supervisor to start up this cat program that we're going to run. We say start cat. Oops. Update, right? Start cat, start car. Don't start the car. Okay. So we can see that now we've sort of dynamically added a process by changing the config file, and that's sort of the advanced stuff you can do with it. You can also go into the foreground of a program. So I can go to the foreground of clock. Sorry. And I can type to cat and it pastes back stuff to me. Not all that interesting, but you can get into the foreground of stuff so you can communicate with processes. So Supervisor CUDL is sort of the way that I usually use Supervisor, or at least control processes that run under Supervisor. Some interesting things that you can do with Supervisor settings. You can actually run more than one instance of a program. So if I go here and uncomment this stuff, by just having a single program statement in here and putting some hair using the numprox configuration thing and the process name configuration thing, when I restart Supervisor, I'm just going to do this to do that. You'll see that I now have 10 cat programs running under it instead of just one. So this is useful if you want to have 4 web servers running. You don't have to have four individual things in the configuration file to run them in. So the final way that you can communicate with Supervisor is to use its XMLRPC API. Thank you. And in order to do that, I'm going to show you a file here. This is something that that opens up a connection to the Supervisor process by going to localhost 9001 RPC2, and it will print the Supervisor state, and it will get process information about a program named clock. So when I run this, this is just standard Python. We could see that it's printing stuff. The first sort of dictionary thing is about Supervisor itself. Supervisor is in state 1, and it's in state name running. The second dictionary here is all about the clock program, and it tells us what the log file is and all that stuff. So you can imagine you can interrogate this thing and write some interesting programs about controlling process state. So that's all about sort of in real time controlling it and having maybe a development environment where you do that stuff and stopping and starting programs. Supervisor is also pretty useful in a production context, because by default, if something exits unexpectedly, and unexpectedly can be defined in several ways, it's got a default, but out of the box, if something exits with any status code other than 0 or 2, it will try to restart that process for you. If it can't restart it for you, it backs off for a little while. It doesn't continue to flap. It backs off for a little while and then tries to start again, and eventually it sort of gives up. But especially if you have something that just kind of you can't fix right now, you don't know why it's crashing, you get a seg fault or something every once in a while, it's really useful because it'll crash and Supervisor just says, oh, it crashed, I'll restart it. So that's typically people enjoy that a lot. The way that this works, like I said, it's initially in this top state called stopped, each process, and it goes into the starting state, and then it might go into back off if it can't start right away. And it might fail and go into fatal mode, but usually it gets to the starting state, and then it becomes running, and then if it actually exits, it goes. If it quits unexpectedly, it'll go into the exit state. So there's this sort of state map that Supervisor keeps track of for you, and tries to put your program in the right place depending on where it is already. One FAQ that people get that people have a lot is that programs that run under Supervisor should not themselves be daemons. So for example, if you run, just for example, like Apache, if you run Apache and type HTTPD enter on your terminal, by default Apache tries to put itself in the background. It tries to daemonize itself, and it gives you control of the terminal back, and then it's probably running in the background. That doesn't really work under Supervisor. Instead, for the example program Apache, you should type HTTPD -D foreground, and that puts it in the foreground so that Supervisor it's not demonizing itself. It doesn't let go of the terminal. This is in contrast to other Supervisor programs, like there's one in Ruby called God. There's another one called Monet. Supervisor itself is in charge of the demonization, which is really good because it's almost never wrong. The other ways to do it, where they keep track of PID files and they try to compare whether the PID that's in the PID file is still running, it's often wrong. But if Supervisor tells you it's up, or your money back, or down, either way. So one other feature that it has that's really interesting are these things called event listeners. And event listeners are just programs that run under Supervisor. Thank you. Run under Supervisor. They take event tokens from Supervisor on their input, and they respond on their standard out. And what they are ways to extend Supervisor and take certain actions when things happen. So, for example, there is a package called SuperLance. You can download it from PyPy. It has, amongst other things, these programs called HTTP OK, Crash Mail, and Memon. What HTTP OK does is it continually pokes a URL that you supply. And if it does not get a 200 response from that URL, it will restart a program that is running under Supervisor. So that's, even though the program didn't crash, maybe it's just stuck and it needs to be restarted, and that's a good way for it to do that. There's another program called Crash Mail, so if anything fails, Supervisor will send an email when a program crashes. There's another program called Memon that will restart a process if it goes over some configurable amount of RAM usage. So if you have a leaky process and everything. So these are all sort of production-y things that are very useful when things aren't quite working as they should and you have some problem processes that you need to take care of. And of course, you can write your own one of these. These are all documented in the docs. So in the real world, people tend to use the system-supplied supervisor, under Ubuntu or Red Hat or whatever, and they will stick little configuration snippets, parts of the config file that I showed before, inside of files in this etc supervisor d.d directory, and that's really useful because typically what you'll do if you want to automate deployment of something, you want to set up a server somewhere, you'll use Ansible or SaltStack or Puppet or whatever, Fabric or whatever, to lay down some files on the file system that represent the way you want things to be. One of those files is going to be a snippet inside of this supervisor d.d directory that says start a web server, and start Redis. And another file might say start Redis. And you just sort of jam those things in there, and then of course the next time it starts, next time your computer starts, all those programs will start up for you. That's typically what I've seen. I guess another thing it's often used for is to start multiple programs inside a Docker container. Who here is using Docker right now? Oh, that's a lot, okay. Don't mean to be Docker-centric. I know there's other container systems as well. So history, this thing has been around forever, since 2004. Has 3 major releases and many minor ones. The latest stable is the 3 series. Sometime this year, Supervisor 4.0 will be released, and it will work under, currently, the current release of Supervisor only works on Python 2. It will work under Python 3, and it will add this signal command. Those are the 2 big things. If in the meantime you need it to run under Python 3, master works under Python 3. What will become Supervisor 4 runs under Python 3. And I'm hoping that something comes along to make Supervisor not necessary anymore. I haven't found quite that thing yet. That would be great. But in the meantime, we'll keep going. And that's it. That's it for me. I appreciate it.
If anyone has any questions, please come to the mic. We have about 5 minutes.
Hi. Have you considered making the default configuration network-based in the way that basically you could just run a blank supervisor on all your machines and then send job requests and automatically maybe allocate and such?
Can you say it again? Make it.
I'm sorry.
It's okay.
Have you considered making the default configuration over the network, basically, where you would start Supervisor with no config, and the default mode of operation would be you call out to it from some tool, and maybe it calls out to 20 boxes and say, start this thing?
Well, Supervisor itself doesn't do that, but there are things that wrap Supervisor. If you go to the supervisord.org site, there are things that do almost exactly what you're talking about, and they manage a bunch of machines, each one of which is running Supervisor, and they'll start and stop processes. Probably that's not going to happen for the core thing, because it really is sort of a separate level above the core stuff. But I know what you're talking about. It is useful to be able to do that. So.
We use Supervisor D frequently, so thank you for your work. I did have a question. You touched on daemonization as a potential problem. We've occasionally seen issues with processes that spawn child processes not being cleanly kept up.
Yep.
On shutdown or whatnot. Do you have any best practices handling those, like Celery or Unicorn, that do that?
Yeah, there is. This should probably be the default because that's a very common problem. There is a setting called Kill as Group in the Program Settings section. If you set that to 1, I suspect that your problems will go away, because what it does is, instead of kill the process that you started, it kills the process group that you started. So it'll kill the process plus any of its children. It probably should be the default. In particular, lots of Flask users have this problem where, because the actual problem is that the program you started doesn't clean up its children properly, and the Flask web server doesn't clean up its. So lots of Flask users are annoyed by that. It should be the default, probably.
All right, thank you.
You're welcome.
Yes, so I know Supervisor has a priority to control what order things will start. Are there any plans to add anything about true dependencies on don't start this process until the other one finishes?
There is a request in the issue tracker that has lots of people plus wanting it, which isn't terribly useful, but if they were all dollar bills, maybe. But yes, I mean, it would be nice, and probably that we should take it to the mailing list and see who's willing to contribute code to get that done. Yeah, thank you.
We're currently using a custom fork of daemon tools, and I'm wondering if you could give me some pros and cons. Are there good reasons to switch to Supervisor from daemon tools?
Well, I will try to talk you out of it first, which is that daemon tools is far more secure than Supervisor is. Daemon tools, I mean, Daniel J. Bernstein is very, very security conscious, and daemon tools is a very nice piece of work and does almost the same thing as Supervisor does. It's just a lot harder to set up. It's, you know, there are things about its permissions and stuff in the file system where you have to get it right, and Supervisor is just in any file, so it's easy to get started with. Supervisor is also extensible. You know, you can control it programmatically and extend it a little bit easier than daemon tools. So if that's important to you, then you can do that. Hi, Leonard.
Hi, so this is not an actual question, but a comment to make sure, because I don't really think you said that. One of the big benefits with Supervisor is that you can run infinite amounts of them. So you can have, for example, the development environment for all your web servers, and they can all run all the stuff they need under Supervisor, and each one have its own supervisor. It's very useful for development in that situation.
Yeah, and
so that's why it's hard to replace with other stuff.
Yeah, well, that's true. In particular, like the way I tend to use it is that I'm a consultant, so I have a bunch of customers, and each one of those customers has some number of projects, and each one of those projects may have some number of variations. So for each variation of each project, for each customer, I'll have a Supervisor configuration, and I'll start one of those things, and maybe I'll have a couple of them running or whatever. But I tend to automate that stuff, template that stuff out, and then it just starts. When I want to work on that project, I start up that Supervisor, and I'm done. So that's useful.
So that brings us to the end of our talks for today. There's lightning talks now. Please give a round of applause to Chris McDonough.
Thank you.